PIC. PIC is the notations given that specific core loss in core material corresponding to flux density in the core. PIY is equal to specific core loss in weight per kg of core material corresponding to flux density in the yoke. GIC is equal to weight of core in kg. GIY is equal to weight of yoke in kg. So here is total iron loss is equal to PIC GIC plus PIY. GIY is equal to PI. It is denoted by watt. So the core loss component is equal to core loss component is equal to IC is equal to total iron loss upon voltage. It is denoted its so you can see IC is equal to P1 by Vp into ampere. So for no load current, IO is equal to square root of I square M plus square root of IC ampere. Now see, there is no load current for three-phase transformer. So what is the difference between single-phase transformer and three-phase transformer? In single-phase transformer, there are only two yokes and two limbs in single-phase transformer, and in three-phase transformer, it has three limbs plus two yoke. So compulsory, it is a main difference between single phase transformer and three phase transformer. So here is equation for no load current of three phase transformer. As you can see, so here is you can see the total iron loss of all three phases. Though no load current per phase for three phase transformer is IO is equal to square root of I square M plus square root of IC and it is calculated in ampere. So here is copper losses, I square R losses. These are the losses taking place in the conductor of transformer. Copper is most commonly used conductor. So the copper losses are due to the wasted in the conductor due to resistance of primary and secondary windings. These losses depend on the magnitude of current flowing in the winding as well as the resistance of primary and secondary winding. As the current in the transformer depends upon the load on the transformer and the load on the transformer keeps on changing, these losses change and hence they are called as variable losses. Total copper losses in the transformer is the addition of copper losses in the primary winding and copper losses in the secondary winding. Means we have to calculate the copper loss in primary winding as well as secondary winding, and total loss is the addition of primary winding loss and copper loss in secondary winding. This is the procedure for the copper losses in the transformer. Total copper losses are calculated as I square P RP plus I square S RS, and it is denoted in watts, where IP and IS is nothing but the current in the primary and secondary winding respectively. RP and RS is nothing but the resistance of primary and secondary winding. The stray load loss are usually taken as a 15% of the total copper loss. Means we can write PC is equal to total copper loss plus 0.15 PC, means it is your stray loss, stray load loss, core losses and iron losses. These are the losses taking place in the core of transformer, as the core material is generally iron or its alloy. The components are generally referred as iron losses. Iron losses have two components, hysteresis loss and eddy current loss. When alternating flux is set up in the magnetic core of the transformer, it undergoes a cycle of magnetization and demagnetization. Due to hysteresis effect, there is loss and it is called as hysteresis loss. Hysteresis loss is what is meant by hysteresis. The hysteresis means the phenomenon in which the value of physical property lags behind changes in the effect causing it. When alternating flux is set up in the magnetic core of the transformer, it undergoes a cycle of magnetization and demagnetization. Due to hysteresis effect, there is loss in, and it is called as hysteresis loss because it is lagging. This loss depends upon the maximum flux density, frequency of the supply and volume of the core. Due to alternating flux, an EMF is induced in the core, which circulates eddy currents in the core, and the losses taking place due to this eddy current are called as eddy current losses. These losses depends upon the maximum flux density and frequency of the supply and thickness of the core. These losses depend upon flux, which is constant, and hence these losses are called as constant losses. Now, there is procedure to estimate the core losses in the transformer.